Okay, so this is going to be a live walkthrough of that exploration activity for the serial dataset to practice some of these dplyr functions. So here you can see I have my setup chunk. We'll leave that alone. That's just for knitting purposes. And then I've got my library. In this case, I just want the tidyverse. I'll go ahead and run that code. And then I'm going to load up the data. So here we go. Our serials data is loading from a URL. Run that baby. Bam. Now we can see that R gives us this chatty output, and it might seem alarming because it's in red colors, but it's not. It's just telling us, here's all the variables I found, and here's what I assume them to be. These 3 are character, and the rest are double. Whenever I load up a data set, I like to hop down to the console here and just look at it. I personally find that easier to get a feel for what's happening. Okay, I've got the name of the cereal, the manufacturer, the type, and all these measurements to do with the nutritional values. So hopefully you took a look at the documentation. I've already read it, so I'm not going to click it now. And so the first thing we'll do is just get a feel for the data set. A lot of different ways to do it. Like I just showed you, I like this head function just to look at the real data. Structure is always useful. And summary is always useful. And maybe you noticed that it's okay to put serials in as an argument, or you can pipe it in, whatever you prefer. Those work the same. And so there we go. Structure gave us back the size of this tibble of this data frame, 77 observations, 16 variables. Here they all are again of their types and a few of their values. Or similarly, we could see all the summaries of this data. Now looking at this summary, I notice a couple problems in this data set. And this is the type of thing that you'll get used to. I'll often ask you to clean the data. And I'm not fishing for anything specific. I'm just saying take a look and see what's reasonable. So one thing I'm noticing here is that manufacturer and type, these are of type character, because they are indeed just words. But I understand that these should be categories. These guys should be factors, because there's only a few manufacturers in this data set, and there's only, I believe, 2 types of cereal, hot and cold. But there's another bigger problem here that I'm noticing, and maybe you've spotted it, maybe not. I'm seeing right here that some of the cereals have negative sugar, negative carbohydrates, negative potassium. And of course that makes 0 sense, right? We're not going to lose sugar by eating a cereal. So I'm inferring that what's happening here, and you could find this if you dug into the documentation, is that missing values were marked as -1. So instead of putting a blank or an NA where they were missing data for a certain cereal, what they put is a -1 in a variable where negatives don't make sense. So I want to deal with these 2 problems here. I'd like to clean the data. I'm going to take my serials data set, pipe it into Mutate. First, I'll fix the easier problem. So I wanted that manufacturer variable to actually be a factor. I'm replacing the original manufacturer with the factored version. And similarly for type, is that what it's called? Yes, type. I want that one to be a factor. Now the next thing that I want to do is I want to replace all of these -1s with the actual missing symbol, with the NA symbol. Now I could consider dropping all the rows of this data set. I could consider using filter to say, let's just get rid of anything that has a -1 in one of these variables. That seems like a bad idea to me, because what's happening there is that you're getting rid of a bunch of data, and whatever cereal this is that's missing the data for carbohydrates doesn't appear to be missing that data for fibers. So if we were studying fibers, but we started by dropping out that cereal, we would be losing some data. So instead, what I think I'd like to do is I'd like to replace all of those -1s with NAs, so that later on when I use functions, it's very clear that those are missing values, not negative sugar. So I'm going to use a function called NAIF. I found this by Googling, and if I use this question mark trick, I can take a look at the documentation here. And so we can see in this pane, NAIF is a function that wants, as its first argument, a vector, and as its second argument, the value that we want to replace with NA. In this case, that'll be -1. So I can't quite just put NAIF at the end of this pipe, because what's coming out of this pipeline here, that's a data frame. But NAIF doesn't want a data frame. It wants a vector. Really, it wants a variable, which it's going to modify. So really what I'm still doing is I'm still mutating this data set. And I actually want to mutate every single variable in this data set. So I'm going to use mutate all. And for every single variable, what I want to do is something where I replace -1 with an NA. Now what should I put in that first argument? Well, the documentation tells me it should be a vector, so it's going to be the name of the variable I want to modify. Except in this case, I'm not doing just one variable, I want to do all of them. And so you'll see in a lot of these tidyverse functions, we'll get to this in a couple weeks in a much more deep way, there's a trick where you can say, look, here comes, whoops, don't delete that whole thing, here comes kind of a general direction. And so what I want you to do is I want you to take every single variable in this data set, and I want you to put each one of them into the first argument of NA-if. So this tilde and a dot trick, it says for every single variable we're concerned with, what we're going to do is put it in the first argument of NA-if. So let's take a look at that. Bam! Hopefully that worked. Perhaps if we wanted to make sure it worked, we could pipe it to summary and see if those -1s are still there, and indeed we can see that they're not. Now we have NAs instead of negative values. So you've probably noticed that this was just figuring out what we need to do to the data set. We want to save it as something. In this case, I'm just going to overwrite the original, and I don't want to save the summary, I want to save that. There's our final code, we can run it, it adjusts our original data frame, and we can move on to the next steps of this process. So you were asked to summarize the mean and median and standard deviation of sugar. Let's try that. Oops. So the function, of course, is summarize, as you can infer. And what we're going to do is we want to summarize the variable sugar, but we want the mean and median. Let's go across just sugar. And the two types of functions we want to do are mean and median. So do we see how that across function, the first argument was the variables we want, in this case just sugar, and the second argument was which functions we want to use to summarize. And now it's not happy, column sugar does not exist. Let's just live troubleshoot this. So is there a column called sugar in cereals? Aha, sugars, there's my problem. I'm going to leave this in the video because this will show you this is super common. I run into these errors. This should be the easiest task for me, and it is pretty easy, but of course I remembered sugar instead of sugars, and I had to check and see what was going on. So there we go. Oh dear, we've got NAs happening. Well, where'd that come from? That came from the fact that there was missing data. So now in this case, because we're only concerned with sugar, it's not that dangerous to just drop the NA. Notice that we're not updating the whole data set. We're not tossing that data out forever. We're just adding it to the pipeline and saying, for this particular analysis, I'm okay with throwing out missing data. And there we have the mean and median for sugar content per serving. And then I ask you for the total calories of all cereals. This one is actually a little easier. We're going to take cereals, type it again to summarize. And then what do we want? Well, I just want the sum of calories. And that's going to sum over every single cereal since I haven't put anything in the pipeline to narrow it down. And there we go. All right, so our next task was a mutate task. What I want you to notice is that in these two pipelines, I'm going to go ahead and zoom into that window. That trick I just did there was Control-Shift-1. I can do Control-Shift-1 to come back to all four panes, Control-Shift-1 to zoom in. So in these two steps that I just did, notice that I didn't save my output anywhere. I didn't update the cereals dataset. And that was on purpose, because this is one of those situations where I just want to do a calculation and see the answer. I'm not trying to adjust the dataset, I'm just trying to spit out some results. Now in this mutate step, I am actually trying to update the dataset. So I'm going to remember to put that assignment operator from the beginning. Now I'm going to pipe through mutate. And what am I trying to mutate? Well, I want a new variable called cal per cup. And that variable is going to be the number of calories per cup. We have our calories variable, that one's per serving. And then we have our serving variable, which is number of cups per serving. Cups, there we go, cups, sorry. number of cups per serving. And so calories divided by cups, that should be my calories per cup. Ta-da, I did it. Notice that nothing printed out. That's because instead of asking R to please spit out some information, I stored that information under the name cereals. If I wanted to double check my work, I could summarize cereals again, or maybe I could summarize just the calorie per cup variable. I can see that it calculated just fine. I'm going to delete this now that I've seen that summary, because when I knit my final document, I don't really want it to be there. I didn't need that summary to print out in my final document. Okay, so now I would like to filter, and now I think I asked you to make a new data set, so let's just make this new data set called cereals. And it's going to be my original one, but filtered only into Kellogg. Manufacturer equals, and K is Kellogg in this data. And then I also asked you then to arrange this data set. So I want my Kellogg cereals to be the original, but arranged by that new variable cal per cup. Now, I think I've done every step correctly, but that seemed a little bit tedious, right? That seemed like we had to do all these 3 separate steps. So a better way to do this would have been to do it all in one chunk. So I can add a new chunk, and I can just say maybe wrangle. That's going to be my name of that chunk. And my Kellogg cereal is just going to be to take the original cereals, plural, there we go, and then pipe it through this entire pipeline. So the first step was to mutate, and then once I'm done mutating, my next step was to filter that guy into arrange. And so now I've accomplished this task with just one code chunk. I can test that out. Bam, there we go. Let's check out our Kellogg cereals. And that looks pretty good. And now for visualizing the data, this was really up to you how you want to visualize. The important thing was this notion of being able to pipe our data set through a process. Let's say, let's look at only low-calorie cereals. So I'm going to filter such that calories is less than, I'll choose the median, 110. And among these low-calorie cereals, then maybe that's what I want to plot. And maybe I'm going to make a plot that says, okay, what is the histogram of proteins? So low-calorie cereals have high proteins. Aesthetic. I make this mistake all the time. Letting you see all my mistakes so that you understand, first of all, that I make them all the time too, and you should not feel bad when you make them. Okay, so kind of the ugliest histogram. I hope that you came up with a better plot, but the idea here is that we can pipe through a filtration step, a select step, a mutation step, anything we want to pipe through, and send that along to ggplot. The last thing we always want to do is knit. Let's see that final beautiful document. Let's make sure that we haven't made any silly mistakes throughout our document. Zoom out to see the progress here. It's working on it. And fingers crossed, here we go. Awesome, we got through the whole process. It's going to pop up, ta-da, my nice document. And there it is, there's my exploration. Now, if I were making some adjustments to this document, I might say to myself, did I really want to see all this output from Tidyverse? Did I really need to see all this output from Read CSV? We'll talk about that next.